Hello guys, myself meetnagadia, and today we'll be doing the pre-processing part. So welcome to this series of Wikipedia where we are scraping the data from Wikipedia and will implement that into a model that will do something using this web scrap data. So our end goal would be to either perform topic modeling or either perform text classification based on the data that we have scraped. So we have already uploaded two videos to the this series. One where we explained the how to use the Wikipedia module that we have to scrape data. That was a tutorial for that particular library. In the second video we implemented the scraping part. How can we scrape data and store it into a CSV file? So I would highly recommend you to watch those two parts because it would be necessary for those parts to be done properly, then we can move with this part. So this is the third part, and here we'll be performing the pre-processing part for the data so that we can perform data modeling. So our end goal would be to either perform data modeling or text classification, or if you just want to clean your data, this process will help you. Now, if you ask, why should we perform data cleaning? Why can't we just directly use that? Because sometimes it may happen that the data is inconsistent or it may be a messy data. So we must, first clean the data so that it gets in a proper format that we are eligible to work with or we are comfortable working with that data. Also, cleaning data reduces the mistake in the process that can negatively affect the model or even the data that we have. It can manipulate things that your model may get overfitted upon or even underfit. Data cleaning can also help in easily mapping various functions to your data. And if we talk about the business related thing, then clean data may help in pictorial representation of that data. We can create bar charts and things like that to boost our customer acquisition, improve our decision making based on the data that we have, as well as we can streamline business practices, reducing the duplicates from the databases, etc., enhance productivity, increase sales and revenue. When we have data and that too in a format that it is easily understandable, then we can easily show it to our customers and can increase our sales and revenues. So having a clean database and a clean data is crucial for even for marketing purposes, so that we can easily target the audience that we want to target. So here are some steps that we can perform to take the data that is, even structured, unstructured, and convert into a form that we are most suitable working with. So here I have one good block. I will share this notebook we are using as of now. I am using Google Colab. So I will share this Google Colab link in the description to check it out. Here is one of the good blog that I read about data cleaning. So here I'm mentioning it. So first step would be to import libraries for pre-processing data. Here we are just using NLTK for cleaning purposes. You can use any other libraries as you wish. So first of all, we'll just import the regress, sorry, not regression. Then we will be importing pandas, numpy, NLTK, and from NLTK we'll be importing the stock words. We first need to download the punkt and as well as stock words if you haven't. So this is just the importing libraries. In the next part, we will load our CSV file. if you have watched previous videos, you know that we have scraped some data and we stored into the CSV file. So I will be uploading that CSV file from the Google Drive, because I stored it in the Google Drive, and now we are just importing here. So for that, what you can do is you can upload your file to the Google Drive, and you can connect your collab with the, see here, you can see it is already mounted, so it's showing unmount. When you will first click here, it will be option of mounting, then you have to just give the permissions, allow it, and it will connect the Google Drive to your collab. So you can just then here, then you will get the drive and the sample data. So in your drive, wherever you have stored, in my drive, this are all the my content, so your may be different. So you can get your file and just copy path. Let's say I'll show you one. So let's say if I have this, let's say I have this, so I can just copy path here and I can just paste it here. So if I take it, I will just have to paste. This is just the data underscore tf. We are reading the CSV file using Panda. So just paste your file path here. Note that if the file path is incorrect, the data will not be load correctly. So please make sure that you are giving your path correctly. Then we are just uh, checking the dimensions of the data. Then we are checking what all columns that we have, as we have known in the previous videos that we will be collecting title, content, URL, and links. So this is how it looks like. So this is how the data looks like. It has title, it has content, it has URL, and it has links. So I'm checking for null values, if I have any null values. So as you can see here, there are no null values present. And this is again column checking. I think I did it before, but okay, no issues. I just commented. Oh, by the way, if you are seeing here cats and dogs and crabs, it's because I have enabled. We'll go to settings. Here is the dark theme, and if you go under miscellaneous, you can see here corgi, kitty, and cat. You can enable that. Yep. So anyways, that's the few tricks I learned on Google that were amazing. So I just implemented them myself. Yeah. So here I'm just printing the content that we have. So as you can see here, there are contents. Then we are taking the titles and checking if there are any repetitions in the titles. So yeah, as far as we get to know that the computer security has 8 times repeating in the data, and rest is this. So now this is just about, we explored a bit about data set that we had. So now we will move on with the data pre-processing step. Now note that we will only take content part of the data. That is, we will only process the data that is available in the text form, and only that data we process is the text data. Other data with URLs, links, and are not relevant for us. What I mean to say, if we see the data set here, we have title, we have content, we have URL, and we have links. So what I mean to say, by the way, these links are actually the hyper meter, which will be redirecting using this URLs. Okay, so for us, the main part here would be the content and not the title, nor URL, nor links. So what we will do is we'll store the content into something, and then we'll just pre-process the content, because we don't want the other things. Yeah, but if we are pre-process, if we are performing here, my end goal would be to perform topic modeling. So I don't need the URL, links, or titles. Yeah, but I can use titles later on. But as of now, we don't need any of these. If we are performing text classification, then we would need title and content. We can skip URL and links. But as of now, I am just taking the content and dropping the title, URL, and links. So here we are just taking what we here did is we took the data variable and we are just storing the content of from the data underscore df. We're just taking the data, that is content, from the data underscore df, and we are storing it to the data. Yeah. So first step is converting data to str format so we can carry out our work effectively. So yeah, as we know that it is the string format, so we'll be dealing with the strings. So as it is the text data, so we are first converting it to the string type, and now we are checking if the data type of our data frame is string or not. We can usually skip this step because it's not that much relevant, but sometimes it may happen when the data is in list format, so we kind of change. So it depends upon the data that you have. So here it is already string, but we are always converting to make sure it is in the correct format. So now we're moving on to the step 2, that is converting text to lower characters. I suggest this is sometime viable and sometime not, because when we are performing topic modeling, it's it's okay if we have uh, the data in caps or even in smaller data. It doesn't matter, because at the end of the day we are converting it to lower. So I thought it would be much easier if we converted it first and not let the model convert, because it sometimes it take more time. So here we are just using str.lower on the data and again storing that thing into the data, and we are just then printing what the output looks like. So as you can see, everything is lowered here now. Step 3. Here we create a function to remove all the punctuations from the text to clean the corpus. So as you can see here, we have some punctuations. For example, this round braces here, parenthesis type, and again we have a comma, a colon. So we want to remove this thing. So what we will do is we'll create a variable called punct to remove, which is punctuation to remove, and we'll store all the punctuations that we know. All the things that we want to remove from the text, we will put it here. And now we will just create a function def remove underscore punctuation, and it takes one parameter which is text. Now what we will do here is we'll say this is a custom function to remove the punctuation. This is a comment. Now what we will be returning is we want to remove all of these punctuations and replace it with a single space. So now we will be using text dot translate. Text is the string that we will be passing here, and str dot trans make will replace that thing, and we are replacing the punctuations to remove. From the punctuations to remove, it will check the string and then it will be removing. Then we are using data is equals to data dot apply. We'll be using lambda function and passing the whole string, whole corpus of the data frame that we have, and it will one by one clean all the corpus. Oops. Yep. So as you can see now, we do not have any punctuations or things like that. As you can see, we do not have any punctuations and we do not have anything like that right now. You can compare the output here, the security, application security. Then we have short. See here, you can see that the round braces has been removed. We need to remove the special characters from the text corpus. Sometimes it may happen there are some special characters that we need to remove. For, let's say example, we have a tweet. We are taking the corpus of Twitter and we have tweet. So the tweet might contain, for example, @meetnagadia is one of the best teachers on YouTube. No, I am not, but I'm just saying, let's consider an example. So @meet, so here is coming. So what we can do is we can again create the same type of function, Instead of having exclamation and all that, here we'll be putting the special characters that are present into the text. So again, it's using the str.make_trans to remove the sentence, to remove the special characters from the string. Then we can see here, I don't think there is any at the rate and all, so because it's not present in the first few, so we can't see it, but in actual it will be removing everything in the sense, all the special characters that it has. Now we will move on with the fourth step. The fourth step is to remove stop words from your corpus. What are stop words? If you ask, stop words may be words that are repeating itself, not in the sense, stop words actually do not affect the sentence. It just is to uh, append two sentence together, or it may be to describe just a bit about the noun or something. So we need to remove we need to remove the stop words. This step is kind of optional, and it also depends upon what task you are performing. Since we are performing topic modeling, we do not need to remove stop words. We can remove stop words if we want to, it's not necessary. Since topic modeling mainly focuses on the structure of the words, it's better not to remove it. So again, it depends upon the task you are performing. If we are performing text classification, then yes, it is required. So here what we can do is, we'll say stop words is equals to set, and then we'll have stop words dot words, and the text that we have is in English, so we'll type in English. So now we'll be storing all the stop words that we have. What we can do is, we can simply just run this cell, and then we'll just print it so that we can get to know what the stop words are. See, shouldn't, a, about, after, again, these are a set of, we can even check the length. So 179. So we have 179 stop words and NLTK stop words that we are removing from the text, but it is optional, so it depends upon you. So now we can also tokenize the text using NLTK. It's again an optional because we are performing topic modeling at the end, but it depends upon what type of task you are doing. So what we can do is, this step is again optional. Since we are performing topic modeling, we don't need to tokenize our data. So what we do here is, we take an empty list, and then we take a for loop and start to tokenize our data. So suppose we have a string like I am meetnagadia. So what would happen is, this is a string. How can we tokenize is, we'll take an empty list and append each word into that list. So I comma m comma meet. So this is how the tokenization works. So we just created the tokenization. Now we can remove, this is again an optional, we can remove the emojis from our corpus. So let's say we have some data that has the emojis in it. So it can be an unstructured data, for example a comment from any social media that has various emojis in it. So how can we remove emojis? So this is one of the examples where we can remove emojis. So here we will be using regress. So we'll create a function remove emoji, and it will take one string. Emoji patterns is equal to recompile re.compile, and will give the this patterns for the emojis, and if we get those patterns, we will just remove it. So here there is one example. remove underscore emoji, and we are saying the game is on, and there are two fire symbols here. So when we see the output, it is just game is on, because we are replacing those emojis with just the simple space. So it will not be something, we are not converting that emoji to a text. There is one again, a example of remove emojis. Then there's the function name, and we are saying hilarious and the funny emoji. As you can see, we are removing emoji, so it's just hilarious. So that's how it is. We removed our emojis from our corpus. So now we will move on with removing of URLs. So suppose our data has few URLs into our text, a string. So how can we remove it? So what we will be doing here is we'll again use regress. So we'll create a function. The next pre-processing step is to remove any URLs present in our corpus. Sometimes it happens that our corpus has some URLs in it. Probably we might need to remove them for our further analysis. So we create a function remove underscore URLs, and we pass into a text. URL patterns is equals to re.compile, and will give the starting of, let's say it could be https or http or www dot and so on. It will just recompile it. It will just compile and replace the everything, and then it will return it. So let's take an example here. The text is driverless AI NLP blog post on this website. So when we use the remove underscore URL, we get driverless AI NLP blog post on. We are removing the URL, so we don't see the URL. It is replaced by a simple space. The next is please refer to link dash dash for the paper. So here again we can see that after link there is some space which is left because we are converting this to a simple space. Suppose say there is no HTTP or HTTPS in the URL link, the function can now capture that as well. So let's say we have this text called say want to know more, check out www.h2o.ai for additional information. So what we can do is we can simply remove, or we can simply detect the www dot. So that's why uh, up we gave the www dot. So we can also detect that, and we'll just replace with a simple space. So that's it. That's how we can remove the URLs. Moving to removing HTML tags. Let's say our text has some data and some string, and then it has some HTML format, or let's say it just have some HTML format. So what we will do is we'll remove the HTML tags and we'll keep the data that it has. For let's say where we will be again creating a function remove underscore HTML. We are giving one text to it. HTML pattern is equals to re.compile, and we are just giving the simple patterns that the HTML has. Then we'll say return HTML patterns, and if it is there, just remove it with a simple space, adding a simple space if you get it. Then we have this text called, first we are giving div, then heading h2o, then we have paragraph automl, and then with e tag we are giving the reference driverless AI, and we are closing the div tag. So when we are printing the remove underscore HTML, that HTML, and we'll passing the text to it, it will return this tag H2O, then auto ML, and then driverless AI. It will be removing all the tags, div tag, h1 tag, then p tag, a tag, and all the closing tags as well. It will just give us the inner data that it has. So that's it. Now we are done with almost pre-processing part. We haven't performed stemming here because it also depends if we need to apply stemming or not. It depends. Now is again the storing part. So what we will do is we'll check the type of the data that we have. It is panda score series. So we'll convert the series into data frame, and we are again checking the data type of the final underscore data that should be is equals to that should be equals to data frame, and then we are just storing the CSV file using the pandas data frame. So it is just sort of normal as data frame dot to underscore CSV, and we'll keeping the index is equals to false, and we are just printing that. So that's it, guys. This was all about the pre-processing part for the Wikipedia that scrape data that we had. I hope you enjoyed this video, and be curious, keep learning. And if you have any suggestions, do let me know in the comments below. I will be linking the whole GitHub series for this as well as the YouTube series, and I have also posted it on Kaggle, so I'll be sharing that link in the description as well. So yep, that's it. All this thing is done, and we'll be moving on with the topic modeling in the next video. So hope we will be meeting there soon, and sorry for the delays in the videos. Till then, bye bye. See you in the next one. Take care. Keep learning. Thank you.